Negative binomial distribution. It is defined as a distribution of the number of trials needed to get the R success or a fixed number of successes denoted as R. It is also known as the Pascal distribution. Okay, so the main characteristics or differences of this distribution is that the number of trials n is not fixed, but the number of successes is fixed. Also, each trial is independent, and only two outcomes are possible, the success and the failure. The probability of success p for each trial is constant. And finally, a random variable y is equal to the number of trials needed to make R success. How we can identify it as a specific type of distribution? The random variable is the number of repeated trials x that produce a certain number of successes R. In other words, it's the number of failures before a success. This is the main difference from the binomial distribution. With a regular binomial distribution, you are looking at the number of successes, but with a negative binomial distribution, it's the number of failures that really counts.
The formulas for the negative binomial distribution are probability is equal to x minus 1 combination r minus 1 times p to the r times 1 minus p to the x minus r, where x is the number of trials, r is the number of successes, and p is the probability of success. The mean is equal to r over p, where r is the number of successes, p is the probability of success. The standard deviation is equal to the square root of r times 1 minus p over p squared, where r is the number of successes, p is the probability of success. The applications of the negative binomial distribution in environmetrics, one is frequently interested in summarizing the changes in the abundance of particular organisms in the environment, either for protection or impact assessment. For example, monitoring the safety of a drinking water source is based on the estimation of the density of an indicator bacteria from the number of organisms found in several water samples. Another example is the estimation of the abundance of threatened species and the impact of habitat changes on their numbers in ecological conservation.
This is the example for the negative binomial distribution. Here, it says, what is the probability that the third 4 will first appear on the third row? How many rows should we expect to need to obtain 3/4? And what is the standard deviation for the number of rows? So, for the first question, we will use the formula the probability. For the second one, we will use the one of the mean, and for the third one, the one for the standard deviation. So, in the problem, we are given that we will do 10 trials, so x is equal to 10. Our number of successes will be 3, and the probability of getting that success will only be or you get a 4 or you don't get a 4, so it's 1/6. Having these 3, we can use now the formula. The probability is equal to 9 combination 2 times 1/6 elevated to the third times 5/6 elevated to the seventh. This will give us an approximation of 0.04 6, 5. So the probability that we can get 3 successes at the 10th trial is minimum. For the second question, how many rows we expect to need to obtain 3/4, we will use the formula of the mean, which is the number of successes we want over the probability of success, which will give us a mean of 18 rows. This means that we will need to do 18 rows in order to have the 3 successes or the 3/4 that we want. And for the last question, the standard deviation is the square root of the number of successes times 1 minus the probability of success over that probability of success elevated to the square, which will give us an approximation of the standard deviation of 9.49 rows.